Hello everyone, welcome to Chapter 7 as we start to discuss quadrilaterals and other polygons. That's the name of the chapter. There's 5 sections in this chapter, the first one being this one here, 7.1, angles of polygons. And so what we're trying to do here is look at what the interior angles measures of polygons are and the exterior angles of measures. We're trying to use them, so we're going to use the interior and the exterior angle measures of some polygons. Now remember, polygon is just a shape, kind of a two-dimensional shape. We could start with a triangle, that is a polygon. It's got 3 sides. Then we can go into quadrilaterals. That has 4 sides, like a rectangle or a square or something like that. Then we also can get into hexagons and pentagons, all those other ones that we've discussed already before. So we're going to be looking at the angle measures of these polygons. But first, let's do a little cartoon here. So here's a teacher that's talking to the class. Well, here we go again. Did anyone here not eat his or her homework on the way to school? So a classic Far Side cartoon. They're all dogs, and so they're all going to eat their homework apparently on the way to school. All right, so page 197 in your notes. You want to turn to 197. It says using interior angles and measures polygons. So first of all, it's the vocabulary page there, and the first vocabulary word is a diagonal. And so it says a diagonal of a polygon is a segment that joins 2 non-consecutive vertices. And so that's what you can put down there on your paper for what a diagonal is in the vocabulary. It is a diagonal of a polygon is a segment. So it's going to be some kind of a segment here inside, like you can see here. And you want to probably draw this out. Do a little shape of a polygon. Draw these out. Label the diagonals here. So you want to label these diagonals on your paper. You have some space there next to it. You can write down the definition and then draw a little picture. Picture is going to be worth a lot more to you than just that definition. So it's going to basically join 2 non-consecutive vertices. So you can see the vertice at B can join with E, making a diagonal. Consecutive would be like B to A. So that's not a diagonal right there. That's going to be a side of that polygon. B to D would be another diagonal right there. So you can also have another one from C to E if we wanted to as well. We could also have a D and A diagonal as well. So those are your diagonals in the polygon. Right below the vocabulary is this theorem, polygon interior angles theorem. Now if I'm going too fast, just stop the video and copy down what you need to copy down. And then you can push play and continue on. So the polygon interior angle theorem. So this is a very important one. And this is the one you want to kind of highlight, that little part right there, n minus 2 times 180. The n here is the number of sides. So that's what n means. N-gon means the number of sides. You could have a 5-sided figure, a pentagon. That would be a 5-sided figure. Or you could have something much bigger. After 12, we don't really have a specific name for it, so we would just say like a 13-gon or a 14-gon. So you might want to put down here that n here is the number of sides in that polygon. Number of sides in the polygon. So like on this one, you can see n equals 6 because there are 6 sides of this polygon. Now if we wanted to figure out what the interior angles are, now we know in a triangle that they're always 180. So in any triangle, the sum of all the interior angles here, all 3 of those, is going to be 180. In a 4-sided figure, it could be a square, rectangle, any 4-sided figure, the sum of all of these interior angles, and this one's always going to be 360. As we keep getting bigger and bigger, 5 sides, 6 sides, 7 sides, it's really going to be helpful to use this. So we would just see that we could do that for here. This is 3, so it would be like 3 minus 2 times 180. Well, 3 minus 2 is 1, so 1 times 180 is 180. Or if it's 4 sides here, this would be 4 minus 2, and then times 180. 4 minus 2 is 2, and we know 2 times 180 is 360. So you can see how it follows there, and then we'll just keep going from there. 5 sides would be 5 minus 2 times 180 giving you the sum of all the measures of the interior angles. So all of these add up to whatever that is. It's going to be different for however many sides you have. Alright, so let's go ahead and use that a little bit on this one. It says find the sum, so just watch this one. Actually, this is number 1 on your extra practice, so if you want to go to that one, you can. But find the sum of the measures of the interior angles of the figure, or you can just kind of watch this and just not worry about it. So we want to count all the sides up here, and you notice there's going to be, if we count them, there's 8 sides. It has an 8-sided figure, which would be an octagon. And so we'd want to put that in there. So n minus 2, so it's 8 minus 2 times 180, which is going to give us 6 times 180. 6 times 180 is 1080. So this is 1080 for this one. So the sum of the measures of this one is 1080. Okay, so on page 199 you can see for number 1 it says octagon. It says find the sum of the measures of the interior angles of the indicated convex polygon. So this has to be a convex polygon. We talked about the difference between convex and concave. Just means there's no indentations in our figure. That's all on the outside. There's no indentations. There's no caves inside that polygon. So if it's an octagon, that means it has 8 sides. We just saw what it was going to be. It's 1080. You can put that down. And I want you to try the same thing for number 2 and number 3. 15 gone, so and 24 gone. Figure out how many, what would be the measure of all the interior angles in a 15 gone and a 24 gone. So the number of sides here is 15, the number of sides on 3 is 24. Go ahead and pause the video for a second and do those 2 and 3, and then come back and you'll check your answers on that. Okay, should have paused the video, so I'm going to show you the answers to 2 and 3 now. So 15 gone would be 15 minus 2, that's going to give us 13, and 13 times 180 on your calculator is 2340. So that's our answer for the number of, or the measure of all the interior angles of a 15 gone. 24 will be 24, oops, I'll clean the click, there we go, 24 minus 2, which would give us 22. And 22 times 180 will give us 3960. So there's the answer for, if it's a 24 gone, all the measures of the interior angles would add up to 3,960. So it's this, talking about the sum of all of those interior angles. Just like we know that the sum of all the interior angles on a triangle is 180, if there's 24 sides, then it's this big number here. Okay, here's another one. Let's take a look at this one. It says the sum of the measures of the interior angles of a convex polygon is 900 degrees. Classify the polygon by the number of sides. So we need to figure out now how many sides is a polygon going to have if the measure or the sum of all the measures of the interior angles is 900. So we're still going to use that same formula, the n minus 2 times 180, except this time we know the answer is 900. We need to figure out the number for n. So we're going to solve this equation for n. And so we can figure out, by doing that, we could divide both sides by 180 to get the n minus 2 by itself. Now you might have thought, I'm going to distribute that 180 in. You could do it that way, but it might just be simpler to divide both sides right now at this point by 180. And that would give you 900 divided by 180 is 5. And now you just got to just add 2 to both sides, giving you 7. So n equals 7, the number of sides is 7, we would call that a heptagon. Remember, 7 sides is called a heptagon. So you need to remember how to classify these based on sides. If there's 5 sides, it's a pentagon. And we've listed this in your notes in previous sections, so you can go back and look for that, or look for that in the book. But we got 5 sides is pentagon, 6 is hexagon, 7 is heptagon, as you can see there, 8 is octagon. 9 is nonagon, like N-O-N, nonagon. 10 is decagon. There is nothing for 11, so 11 would just be 11 gon, the number 11, and then 12 would be a dodecagon. So that's how we could classify them, and anything bigger than 12 is just the number again with gon behind it. Alright, so let's look at going back to page 199. So on page 199 now we got Number 4, it's the same thing we were just looking at. It's 900. So what I want you to write down is actually write down how to do this based on what we just saw. If you need to, pause the video or go back to what we were just looking at to write that down for number 4, do that at this point. And then you'll end up doing 5 and 6 on your own. So try 5 and 6 on your own, and then I'll show you the answers to those two. So 4 would be 7 sides with that 900 there, because you divide by the 180 first, which would give you 5, and then add 2 to give you the 7. So we would call it a heptagon. So that's what we're doing here. We're trying to find the sum of the measures of the interior angles of a convex polygon is given here. It's 900 on this one, 1620 here. So that's what's given to you. We want to classify the polygon by the number of sides. So you need to figure out how many sides is a polygon going to have with the sum of the interior angles being that number. Okay, so do the same thing on this one. So this is what's that little formula. So basically the formula is going to equal this number now, solve for n. So go ahead and pause the video and then try 5 and 6, and then come back and check those answers. Okay, you should have paused the video. So here's the answer for number 5. So start off by just writing out the formula equal to the 1620. And then we're going to divide, just like we saw before. I would divide by 180. That's going to be a little easier to do. Since it's this times 180, you can divide by 180. And now 1620 divided by 180, you can do that on a calculator if you want to do it there. And so that's going to give us 9 when we do that. So now we're just going to add 2 to both sides, and we could know 9 plus 2 is going to give us 11. So it's n is 11 sides, so it's an 11 gon, 11 gon. That's all we say. That's how you can classify it. Number 6, so this is what the formula will equal here. So the formula equals 2880, divide by our 180, and when you do that on the calculator, you'll get 16. We're going to add 2 to both sides, and so it's going to give us 18 for the number of sides, so we would just classify it as an 18 gon. That's all there is to that. All right, let's take a little break here and look at our joke for the day. Joke of the day. Why is a computer so smart? Why is a computer so smart? Can you think of the answer? Here you go. Why is a computer so smart? It listens to its motherboard. That's why. It's a motherboard. Joke of the day. All right, let's go on to the next section here, next part of it. So basically back on, if you just look over on your paper there, it's on 198 is this corollary to the polygon interior angles theorem, and we already talked about this, that the sum of the measures of the interior angles of a quadrilateral is 360. We already talked about that. You can underline this. Interior angles of a quadrilateral is 360. That's always going to be true. Quadrilateral is 4 sides, if you want to write that down. That's what a quadrilateral is. It's going to have 4 sides on this one for quadrilateral. So a corollary always just kind of means it's something having to do with a previous theorem. So it's not its own theorem. It's like that other theorem. So in that case, here's a quadrilateral right here. You can take a look at this one. It's given us interior angles. One of them is x. It wants us to find the value of x. And so we're just going to go ahead and add those up here, 180 plus 121 plus 59. And add that all up. With the x, it's going to equal 360. So it's going to be x plus 288 equals 360. Just subtract 288 and we get 72 for x. So that's all we have to do when it's something like that. We'll look at some of those kind of towards the end there, as you can see, where it says find the value of x on 7 through 10. On page 197 again, so go back to your vocabulary. There's these other vocabularies here. It would be good if you drew the pictures as well. It would be helpful. So it says equilateral polygon just means all sides are congruent. That's what you can write down for that. Equilateral polygon, all sides are congruent. Equiangular, all angles in the interior of the polygon are congruent. Okay, that's important that it says interior because we also have angles on the exterior, and we're going to see that here in a minute. So all angles on the interior of the polygon are congruent if it's an equiangular Now here's the one we want to really understand, is the regular polygon. So a regular polygon is a convex polygon. Again, convex means there is no caves in this. There's no like indentations. So a convex polygon, it's both equilateral and equiangular. So it's both on a regular polygon. So a regular polygon is both equilateral and equiangular, as you can see there. Sides are all the same, angles are all the same. So here's one from the book that's not in your notes here, just showing a home plate of a baseball field. Is the polygon regular? And you can see, well, that they're not all the same angle, so it cannot be regular if they're not all the same angles. It has to be equiangular as well. So it's not regular, as you can see there. Polygon's not equilateral, or equiangular, so it's not regular. Find the measures of C and E. That's going to be these two. They're both going to be the same, as you can see. They're both the same measure. So we now can figure this out. We know these are 90 here, and so we could figure out what's the sum of the interior angles on a 5-sided, this is pentagon here. So we would have to do that, find the sum of the measures. That's going to be 540, as we did that just with the same thing with the 180. So that's going to be 3 times 180 is 540. So knowing that number, now we can make any kind of an equation out of that, and this would be basically our x. There's 2 of them, so we could say 2x, kind of like. And so it's x times x, and then the 90's there, and that would simplify down to 2x plus a 270 equaling our 540. And we just subtract the 270 and then divide by 2, and we get 135 for x. So E and C are both 135 degrees then. They're both the same, they're both 135. Okay, so still back on 198, this other theorem, 7.2, it's the polygon exterior angles theorem. So now we're going to look, kind of, turn the corner here and look at exterior angles instead of interior angles. So the exterior angles of a polygon, as you can see, the polygon doesn't usually come to you in this shape. It doesn't really have these, lines kind of extending out. Usually it just gives you that shape, and that's the polygon. But we can always extend out these sides here to kind of understand or see an exterior angle. Okay, so these always could be lines that could, make exterior angles. So it says the sum of the measures of the exterior angles of a convex polygon, one angle at each vertex, is 360. Okay, so that's going to be really key right there. It is 360. It's always going to be 360. So no matter how many sides you have, whether you have 3 sides all the way to 100 sides or whatever it is, it's still going to be 360. And here's the explanation of why it will always be 360. If we had, if we kind of, mapped off, it says shade one exterior angle of each vertex here, and it's kind of like a slice here, like a slice of a pie or a pizza. And if we kind of cut those out and we had 5 different slices here, now this one is a pentagon because there's 5 sides, so we'd have 5 exterior angles, and it doesn't matter which side of this exterior angle you do because they're going to be the same based on vertical angles. So 4 is the same thing as over here. So that's why it just, shade one exterior angle at each vertex. So you don't want to do both, but you just need one of them because they're both going to be the same. And if you took each one of those as kind of slices of a pizza or a pie, and then you put them together, it'll always make a circle. It'll always make that circular shape there, giving you 360 degrees all the way around. So that's why no matter how many sides you have, whether it's 10 sides, 20 sides, or whatever, it'll always do that. It'll always make 360 degrees around with these exterior angles. Okay? Interior angles are different depending on each polygon. Each different polygon is going to have a different measure for the interior ones. But the exterior angles are always going to be 360 no matter what polygon it is. Okay? So that's something to keep in mind and remember. Okay, so here's one where you can see it says find the value of x, but they're exterior angles here. And so we want to add all of these up, and it's going to equal 360, okay, because they're exterior angles. So we add them all up. the x, the 2x, the 89, the 67, it's going to equal 360. Even though this only has 4 sides, it's going to be 360. If it has 5 sides, it's still 360 on these exterior angles. So that makes 3x here. You put those numbers together, you get 3x plus 156. Subtract the 156 and then divide by 3, and you get 68 for x. So that's how you're finding the value of x. Here's another one from the book, not in your notes, but I can kind of walk you through this one. It says the trampoline shown is shaped like a regular dodecagon. That's going to mean it's got 12 sides, the dodecagon. You need to know that. It says find the measure of each interior angle. Okay, so the measure of each interior angle here, it says it's a regular one, so they're all going to be the same. So we first want to figure out, what's the sum of all of the measures on a dodecagon. And so we're going to be using that same formula we saw before, the n minus 2 times 180. So n is 12 on this one because there's 12 sides to this dodecagon, minus 2. So it gives you 10 times this 180, so it's 1800 for all of those measures. Now, since they're all going to be exactly the same, it wants to find the measure of each interior angle. So we just have to divide this number by 12 to get the equal number. So we just divide by 12, that's what's showing you there. So that gives you 150 degrees for each interior angle. It says find the measure of each exterior angle. Well, we know the exterior angles on a dodecagon are 360 because they're 360 on any polygon. So now we know that number here for the exterior one. We just have to divide by 12 again. So that's just going to be 360 divided by 12 for this one. So 360 divided by 12, and that's going to give you 30 degrees for each exterior angle. Okay, so there's some on your homework that I'll probably want you to do that. Okay, so that's just something to keep in mind. Okay, we're on the home stretch now. We just got 4 more problems to do. It says find the value of x. So we want to first notice these are all interior angles on this one. So we got to look at seeing that this is a 4-sided figure. So we're going to add all of these up here, and it's going to equal, for a quadrilateral, it's always 360. We saw that was that corollary one. So it's going to equal 360 on this one. So adding all those up, x plus 65 plus 45 plus 95, it's going to equal 360. Let's add these numbers together here to kind of simplify that. So now it's going to be x plus 205 equal to 360. Just subtract the 205. We'll get our answer now. When we subtract 205, 360 minus 205 gives us 155. So that's the value of x for number 7. If we look at number 8, so again, this is all interior angles again. We got to count the number of sides to see how many sides we're working with. So we got 1, 2, 3, 4, 5, 6 sides. So if it's 6 sides, we're going to want to figure out, what's the sum of the interior measures on basically a hexagon. It's not a regular hexagon, as you can see, but it's still a hexagon nonetheless. It's got 6 sides. So we want to do that little formula if we don't already know it. So 6 minus 2 is 4, and then 4 times 180 is 720. So you always just want to use that little formula to figure out that number first to know what you're going to have it equal to. So we add all of these up on the inside. Remember this angle here we know is 90, even though it doesn't show us the number, but we know it's 90 there. So add it all up, and it's going to equal to 720. So here we go, x. There's a plus a 140, plus a 150, plus 130, plus 120, plus the 90, that would be here. It's going to equal 720. Adding all these numbers together here, you can just use a calculator or just do scratch paper. You can add all those numbers up. That's going to be 630. So x plus 630 is equal to 720. Just got to subtract the 630. Yeah, so 720 minus 630 gives us 90 for x. So x equals 90 on that one. Okay, so go ahead and pause the video and try these last two, 9 and 10, on your own. 9 again is interior angles. 10, however, is exterior angles. So you need to remember about the exterior angles on number 10. So try 9 and 10 and check those answers once you've done them. Okay, should have paused the video at this point. If you didn't, pause it now and do those 2 problems, 9 and 10. You should have paused the video, so I'm going to go over number 9. So we're going to see, we're going to add up all of these, and we figure out how many sides we have. We have 1, 2, 3, 4, 5 sides. So we can quickly just do the 5 minus 2 times 180, so that would be 3 times 180 is 540. So we got an x, we got a 100, a 70, another x, so basically 2x there. You can combine those together if you want to right now. This is also a 90. So when we get that together, so x and x, 90, 70, and 100. So we can say this is 2x and then add that together there on that side. That makes 260. So 2x plus 260 equals the 540. We want to subtract the 260 first. 540 minus 260 would give us a 280. So now we have 2x is equal to 280. Just got to divide by 2. So 280 divided by 2, that's going to end up giving us 140 for x. So there's your answer for number 9. And then for number 10, this one, it's all exterior angles, so we know the sum is going to equal 360. It will always equal 360 no matter how many sides we had here. So the number of sides doesn't matter. I don't have to count them up. I know it's going to equal 360. I'm just going to add all these together. So we got 4x plus another x plus 90 plus 162. It's equal to 360. So that makes 5x here, and we combine those two numbers together to give us 260. So 5x plus 260 equals 360. Divide or subtract the 260 from both sides. That's going to give us 5x is equal to 100, and then just divide by 5. So 100 divided by 5 gives us 20 for x. So 20 is our answer for x. All right, so that concludes our notes for 7.1, and you should now be ready for starting your assignment. All right, I'll see you later.